Here in London, International Lift Management and Construction present their transformation of a lift system. This contract challenged ILMC to meet the demanding traffic needs of a busy office complex. Bush House stands on a large island site between the Strand and Kingsway. The building was the brainchild of Irving T. Bush of the Bush Terminal Company, New York, and was conceived 60 years ago as an international trade centre. Today, it houses a diverse range of prestigious international companies. Mike Godwin, the chairman of LDP.
Actually, we were approached by the managing agents, JLW Estate Management Services, to look at the total lift system as it was and to make recommendations as to what improvements could be made in terms of equipment changes so that an adequate lift service could be provided for the tenant and users that would be last and be effective over the coming 20 years. Well, in our survey of the traffic that the lifts were currently servicing, we found that there were no defined peaks in the general rules of lift engineering, such as up peak or down peak, which determine the quantity of lift service, but rather that there was a fairly high intensity of random two-way traffic, and really any lift system that replaced the existing one would have to meet this and find a solution to what was in terms of a flexible control policy that would deal with this intensity of demand. Our research and development has enabled us to have a simulator known as LSD4, which runs on a large computer that will model the traffic and the anticipated traffic that we find in a building such as Bush House. Now, having surveyed this building and got a fair idea of that intensity, we can then transfer that to the model of the lift system in the simulator and run many tens of dozens of simulations with different forms of control policy until we have refined the design in terms of the dynamics of the lifts and the flexible control policy, such that we can be fairly sure that it will meet this demand and won't become saturated. We viewed this building, because it is to some extent on a monumental scale, it was the very first purpose-built office building in London in the 1920s, and we thought, in collaboration with the client, that this wants reflecting in any new designs that were put forward. And as it is largely a bronze and marble building, we took some of the features and design configurations from the columns and architectural metalwork in the building and transferred these to the design of the lift car. And then, in order to move the job forward to some kind of final conclusion where costs could be estimated and so on, we placed all of this, our views and specifically all the items of equipment into a very comprehensive specification.
Lift Design Partnership detailed bills of quantities, obtaining prices from their nominated suppliers and subcontractors. LDP's sister company, ILMC, were to act as the management contractor for the refurbishment. Adrian Godwin of ILMC explains.
The contract documentation drawn up was based on the JCT fixed fee form of contract. ILMC provided the client with monthly valuations as the work proceeded. These were then certified by an independent quantity surveyor. There was a total of 14 lifts at Bush House to refurbish, and these were sited in 2 4-car groups and 2 3-car groups. Most of the lifts serve 9 or 10 levels and are either 13 or 14 person capacity. There are 11 geared machines, 2 of which are bottom drive. There are also 3 20 horsepower gearless machines that were retained and refurbished. In discussions with the client, it was clear that we would only be allowed to reconstruct one lift at a time in each block. Furthermore, there was the necessity to interface the existing Otis Autotronic equipment to each new lift in order to provide a minimum of adequate lift service using existing landing touch buttons. At ILMC, we put together the equipment and construction teams to successfully install the new lifts to the specifications given by LDP. The product name we have assigned to this amalgamation of equipment is System 990.
System 990 is an integrated package of the highest specification. In this installation, 40 horsepower General Electric hoist motors drive each car through large centre worm reduction units, maintenance-free bearings being used throughout. To keep motor room noise to a minimum, special magnetic noise attenuating inductors have been fitted to each motor. Control feedback is of great importance for high performance, and 3 units are used in System 990. Firstly, a tacho generator is coupled to the hoist motor. Secondly, a multi-turn absolute position encoder determines the car's position to within 2 millimetres in 40 metres of travel. The mechanical totalizer gives a visual readout. Lastly, in addition to the conventional overspeed governor, an incremental encoder is used to shape the car's speed profile. This allows direct floor-to-floor approach in the shortest time with precise floor level accuracy independent of load variations. It is LDP's policy to specify only the best, and Armour Elevator's Dynaglide solid-state hoist drive has been used in more than 1,000 installations in America. Supplied through an isolating transformer, the Dynaglide drives the motor armature with a varying DC voltage controlled by a 12 thyristor bridge. This eliminates old-fashioned motor generator sets and can make energy savings of 30%. For safety, the Dynaglide controls the motor's shunt field and brake. In addition, fail-safe contactors will shut down the lift instantly any policed function within the Dynaglide circuitry goes outside defined parameters. The car door operator is an existing Otis unit which has been integrated into System 990 by adding sophisticated electronic control. The controller monitors door position and actuating force. Obstructions are detected by ultrasonic and infrared sensors. This arrangement achieves door opening times of 1.7 seconds and dwell times are minimized to 1.5 seconds. System 990 also monitors car load, and empty cars are detected with an ultrasonic sensor. The flight time for a single floor jump between start and finish with doors fully open is only 4 seconds. System 990 is controlled by 3 hierarchical levels of computer. At the top of the tree is the Lift Management Computer, or LMC, which monitors the operation of several groups of lifts and reports status, performance and alarm information to the building management. In the middle is the Group Supervisory Controller, or GSC. This is in charge of the acceptance, assignment and cancellation of landing calls for a group of lifts. This computer also can operate custom design features such as ETA displays, card readers and alphanumeric message displays. At the lowest level, the Single Car Controller, or SCC, provides all the intelligent functions and commands unique to each individual car. This includes the operation of the Dynaglide drive. If a GSC or SCC should fail, the remaining controllers continue to provide a lift service. The aim of System 990 with all its high technology is to make lift travel in the building quick, agreeable and efficient. In addition to the ETA and wait displays, the user can cancel landing calls with 3 touches of the call button. The door's ultrasonic sonoray ensures that the passenger is not touched. After 15 seconds, the doors gently nudge closed, controlled by an infrared beam. The interior of the car, designed to match the Bush House architecture, features polished marble, glass, soft trim and extensive cast bronze decor. The car control station contains an emergency light, car position indicator, car message display, load and in-service indicators, magnetic key switches for door hold and independent service, the alarm button, solid-state touch buttons, door control buttons and an emergency telephone box which automatically opens when the alarm button is pressed. System 990 is designed to cope with rapid random fluctuations in traffic. Dr. Beebe of LDP explains how this works, referring to the mimic display in the motor room.
Information relating to each car is presented in one of 4 columns. The moving blocks represent the cars, and their direction is shown in between the car identification letters at the top and bottom of each column. Car calls appear as 2 small dots. The direction arrows are backgrounded to show that the car is in service and ready to be assigned landing calls. Landing calls are represented by arrows on the left for up and on the right for down. It is the job of the Group Supervisory Controller to assign landing calls to the car most suited to respond. Such assignments are indicated by arrows duplicated in the car status columns of the display. The GSC is constantly reassessing the status of the lift cars and may well reassign a call to a different car before the call is finally answered. At the heart of the Group Supervisory Control computer in System 990 is the CGC algorithm. This algorithm performs landing call assignments. Its aim is not only to minimize landing call waiting times, but to provide a consistent and equal service to all passengers. It is generally accepted that lift traffic can be defined by 3 patterns. Up peak, when passengers arrive at a single floor and distribute throughout the building. The reverse, down peak, when passengers from all floors leave the building via a single floor. And balanced inter-floor traffic, which is the random movement of people about the building to and from all floors. The CGC algorithm is designed to continually adjust to the rapid changes in interfloor traffic, so that there is no need to switch in special features, as some algorithms do, to cope with pre-defined peak patterns. Landing calls are placed in a queue in the order in which they are registered. The CGC algorithm takes each call in turn from the queue and, taking into account registered car calls, assigns it to the car which can provide the fastest response. This process continues until all active cars have one assignment. If there are more registered landing calls than available cars, then the shorter waiting calls are held back, whilst longer waiting ones are answered. Heavy-duty floors are identified from car load weighing equipment, and calls from these floors are pushed forward in the queue to gain preferential treatment. Privileged travellers may use special credit cards to queue jump, and thus obtain immediate service. During the design of the CGC algorithm, the LSD package was used to simulate many hours of lift activity. Using as an index of performance the time taken to respond to 90% of all landing calls, the CGC algorithm was compared with other proprietary algorithms using the LSD simulator. During thousands of hours of simulated lift activity under differing conditions of traffic density and building configuration, the CGC algorithm consistently showed the best performance. All the information displayed on the motor room mimic can be recorded by computer and later processed to produce graphs of landing call response times and car journeys, the same information as produced by the simulator. Thus, it is now possible to demonstrate to the client the truth of claims made about the performance of System 990.
A fundamental philosophy behind the lift design is that maximum information should be available to the client to demonstrate the lift's performance. Adrian Godwin of ILMC again.
Performance information we define as waiting times, and these are given in one of the colour graphics displays available on the lift management computer. This information is vital to provide objective evidence as to the continuous quality of lift service being obtained. The same information provides a good indication of whether certain aspects of maintenance are being carried out effectively. The display being shown here is the waiting times incurred by intending passengers in the centre block during the past 24 hours. Looking more closely at this display, we can see that each individual hall call is represented by a small box. The box is colour-coded according to the waiting time. The up calls are placed above and the down calls placed below the line associated with each floor. In the centre block, the lift served levels basement to 8. The data is broken up into labelled half-hour periods. As the calls, with their relevant waiting times, move past, the recorded status of each car during that period is displayed. Green for in service, red for out of service, and so on. The hall call waiting times are continuously added to the display as they occur. Those that have been on the display for more than 24 hours are discarded. Watching this display for a small amount of time will enable the building manager to quickly gain an overall picture of the performance being obtained. He can also call up the same display for any of the other groups networked to the computer. Other facilities on the lift management computer include an immediate audio-visual notification of any alarm button being pressed in a lift car. Any change in status of a lift, for example it being placed on independent service, is immediately documented on a printer with the time and date. Finally, there is also the facility to immediately send or pre-program a message required to be shown on any or all of the in-car or main floor message displays.
International Lift Management and Construction offer a unique service. Detailed specification ensures full control over the design and quality of materials. The main contractor can then submit his best price. A detailed bill of quantities allows an independent quantity surveyor to certify all valuations and protect the client's interest. LDP's research and development can objectively assess all available lift systems and show that ILMC's System 990 achieves the maximum performance from any given lift resource. All equipment is available before refurbishment of the installation starts, ensuring a minimum of inconvenience to the tenants of an occupied building. Custom designed fixtures, lift cars, landing doors, etc. are the speciality of Lift Design Partnership. The writing of bespoke software to operate features accommodates the special needs of the passenger traffic. A comprehensive lift management system is available which enables a building manager to objectively assess the performance of the refurbished lift system and deal efficiently with users' comments. Planned maintenance on a truly comprehensive scale is available through Interlef, providing a totally dedicated service which ensures lift performance is maintained over future years. The Bush House installation has shown ILMC creating the successful transformation of a lift system, offering unique specifications to the client with special lift traffic needs.